Right, we're looking at the 80011 HandTorque multiplier, a device which is rated to 7,000 Newton meters maximum on the output torque. The rig itself is used for the calibration of the ratio of the HandTorque multipliers, and to do that you would need a multitude of transducers and adapters, most of which would have been supplied with the piece of equipment itself. So when we look at the rig, we need to understand a few safety parameters before we do anything. So with the rig being new, we need to ensure we've bolted the rig to a hard concrete floor. Okay. The reason we're doing this is to maintain stability of the rig when in operation. The rig itself is self-reacting, so there's no forces going into the floor other than the rig being held in place. What should we consider? We need to consider the working environment around the rig. We will be driving an input, so we need to make sure we're not clashing with other personnel within our laboratory. So make that consideration. Once you've bolted your rig down, we then need to think about what are the other potential risks to the operator. When we're working with torque multipliers, you will get a reaction arm. You will not put your fingers or your hands between any reaction points. You will be mindful of moving assemblies. So with the drive input, for example, here, this is all designed to float. The reason this floats is to minimize side loading on the input of your transducers and your hand torque. So pinch hazards, pinch hazards, pinch hazards. When you're assembling transducers, again, just be mindful. Okay, you've got some heavy equipment, wear gloves, be careful when you're dropping transducers into the rig. Okay, so at all times, refer to the manual. This was contained within the rig. If you're missing the manual, contact your Norbar representative and we can get you sent over a PDF copy. So within the manual, you will come across the detail on the air selection, the transducer capacities of the hand torque being used, the calibration method, which is very important. And it's a calibration method which is modelled on what Norbar do in our own laboratories where we have accreditation from UCAS. There will also be pointers again on pinch points. So please take the time, read the manual. It's very important that we do this. I don't want to be visiting a customer where an accident has occurred. Okay. So for the purposes of demonstration and training, we're going to be working with a Norbar HT92 4000 Newton meter transducer. So the first thing we need to understand is A, do we have the adapters? Within the kit supplied with the 80011, we supplied straight reaction arms for the multitude of Norbar HTs, including the 92. So the reaction points are here, and you may well see that the reaction point we have on this particular rig differs slightly to what you've got. This is because this rig has been developed over a long period of time and has received some customized reaction posts dedicated to our UCAS laboratory. The reaction posts that are being supplied to you are fit for purpose. So we've got our hand torque multiplier, 4,000 Newton meters maximum output. We know its nominal ratio, which is 25:1. At Norbar, if you'd like to come round, at Norbar, we have a series of programs which we are not permitted to take out of the laboratory, but we can very quickly enter maximum capacity, nominal ratio, in this case 25:1, and we get output readings, input figures, and an allowable tolerance. So what we can see here, for example, so at full scale, we've got 4,000 Newton meters, and we allow basically a tolerance on our input TD of 20 Newton meters, nominal input 1,600. Again, some of these features we will, in our laboratory, we would collect data on a worksheet and it goes into our bespoke software. Okay, that is software which is developed for our laboratory. You may well wish to work on an Excel sheet where you're taking the transducer, the torque output against the torque input, factoring in your uncertainties to give you those ratios. Again, guidance notes and methods are contained within the manual, but I'm going to show you the system based on what Norbar are doing. So I've got my outputs, which are 800, 1600 newton meters, 2400, 3200, and at full scale 4000. Okay, and against my inputs. So what I'm going to do, I'm going to make a note of these on a worksheet, and then we're going to assemble the rig, and we're going to show you what transducers and what input, sorry, which output transducers and which input transducers you should be using. Okay, so I'm using one of the Norbar worksheets. So what I've actually done now, my nominal output torque have transferred to the sheet. So as I said before, 800, 1600, 2400, 3200, full scale 4000. Then we've got series 1, 2, 3, 4. So for series 1, we're going to load to give us a nominal output of 800. We're going to record what that input torque value was. We're then going to go to 1600 and record that value, so on until we get to 4000. Once we've done this, we're going to remove our load, and again we'll show you on the video how this happens. We're going to remove our load, we're going to turn the output of the HT through 90 degrees in the clockwise direction and repeat that test. We're going to remove our load, we're going to turn through 90 degrees, repeat, and we're going to do that one more time until we've got 4 planes of calibration. How you calculate that data, I'm going to suggest you use either an Excel sheet or you do it via a bespoke program. Norbar don't provide the calibration software for using this rig. Okay, so as I said before, we're going to work with a 4000 Newton meter transducer. Let's show you how we get that in the rig. So we need to disassemble, taking off the top plate. And of course the top plate, just want to mention this, the top plate consists of a torque multiplier with an anti-wind-up ratchet. So when we're winding in the clockwise direction, we'd have our anti-wind-up pushed into the clockwise, so we're driving in torque and we're maintaining that value. Okay. When we get to the point of relaxation, I'm going to show you what you have to do, and again, you need to exercise care. So it's very important that you follow the instructions given in this video, and if you have any questions, ask those questions before you commit to working with the job. Okay, so I said that we were working with a 4000 Newton meter hand torque. Norbar's laboratory is very fortunate. As we manufacture transducers, we've got many to choose from, and what we want to do is select the best fit. So I've got a 5000 Newton meter transducer measuring the output torque, and I'm going to be using a 250 Newton meter transducer measuring the input torque. So effectively, I've selected quite easily from our large stock of transducers in our laboratory the appropriate transducers. Many end users would have a vast range, and it may be in certain instances you may need to look at investing into a missing transducer to fill maybe a gap within your range. So if we can just place the camera down here, I've installed our 4000 transducer. I've also installed a 1.5 inch to 1 inch drive adapter. This is because my HandTorque has a 1 inch output. Okay, I've already connected this to the TTT, which I'm using as a display device over here. Okay, so I'm now going to drop my HandTorque into the rig, and what I've already done, just to make my life a little bit easier, I've actually turned the input so that my square drive drops in and allows me to sit nicely on a reaction point. Okay, so that's our HandTorque dropped in. We just need to ensure that if you've got an anti-wind-up mechanism installed, we're working in the clockwise direction. We've pushed our anti-wind-up bar to allow the clockwise direction to be functional. Okay. Okay, second piece, we're going to use a 3/4 to 3/4 male. Drop into the transducer. A 3/4 1/2 inch. Okay, so we can now drop this assembly into our HandTorque. Okay, so we've now got output transducer, HandTorque installed with the appropriate reaction, input transducer. So we're now going to just connect our input drive transducer. So again, taking our transducer lead, hopefully at TTT, we're going to do feed that in. And, you know, given the location of the transducers, it can sometimes be a little bit troublesome, but there we are, we're in place. So we've got input transducer, HT, output transducer. So what we can now do, we've got our top plate, and again, the commercially sold 80011s may differ slightly to what we have in our laboratory. For example, you may not have this handle. However, this mechanism you're seeing here is exactly the same. So, noting that we've got a drive output, this is what we're going to engage onto. So we're going to lift, again, taking care not to trap our fingers. So we're going to come down onto our drive square. Okay, now we're in position. And what you can see here, you can actually see you've got this float. This is very important because as we start to load the rig, the actual drive input will start to find its own centers. Okay, so what we're going to do, we're just going to have a quick look at the rig. We've got the reaction in place, it's secure. We put our circlip to hold our reaction in place. We've got the correct output transducer, we've got the correct input transducer, our anti-wind-up ratchets are in the correct position, they're both going in the clockwise. So we're now in a position to start loading the rig. So you've got a drive input crank. Okay, so we put our crank onto the rig. What we're going to do, according to our calibration method we supply in the manual, we're going to load to full scale. Okay, we're going to do that. We're going to load to full scale 1, 2, 3 times, remove all load, and then set the zeros on the transducers. So from here, and what you'll see here is once the rig starts to take load, the whole mechanism tightens up. Okay, 4,000. We're just going to hold that for a nominal 30 seconds. Okay, from here, to release the rig, and this is very important, we're going to take our crank handle, we're going to apply a small amount of pressure, and we're going to release the anti-wind-up if one is fitted on your HT under test. We're then going to release the anti-wind-up on our input drive here, and then we're going to relax under control. We are not going to let go, we're going to be under control. Okay, from here, ensure that the load is fully released, and that's not just on the input, just check that your output is loose. By what you're doing there, to check your output, you're looking for clearance at the reaction point here. Okay, so we've released our load. What we can now do is load again, second time, load again, third time. Okay, we're going to release, and then we're going to zero. So we zero the input, zero the output, zero the input. So we're now in a position to actually start our calibration run. And again, to remind you, we're going to be working at 20% intervals. So our first nominal output torque is going to be 800 Newton meters. Okay, so again, what we're going to be doing is ensuring before we start our anti-wind-up pins are pushed back into the correct direction. Okay, so we've got them both in the clockwise. We can now start to wind. And what I'm looking for is 800 Newton meters. Now, Norbar state a tolerance of plus or minus 4% typically across HandTorque multipliers. So we do have a level of variance, and you can use that tolerance in your favour. For the purpose of the video today, we're going to go straight to a nominal 800. This is a test or demonstration HT, and the results are as found, and they are always as found because there is no adjustment you can make to a HandTorque. The calibration or the ratio depends on the ovality of the annulus, the way the gears have been cut, and at the low end you can also get frictional characteristics. But this gives you the ability to say to your end users, your customers, what that HandTorque multiplier is delivering. Okay, so with zeroing our transducers, we're zeroing them in track mode. Now, what we're going to do next is start loading to that first figure, which is 800 Newton meters on the output. And it's the output transducer that you are watching to give you that figure. You're then recording the inputs as you go up. So, what I'm going to do now, change our TTTs or T-box, whatever you're using, change that to dial electronic. We want a peak hold function now. Okay, so we're in a position, we've changed our wind-ups back, so we're now going to wind up. And again, you might need to be very careful how you're winding your input, because the transducers are obviously very sensitive, and what you don't want to do is overshoot. So when we start to get close, what we can do, so let's look at the screens. I've got 800 and I've got 32.11. So we can record 32.11 as our first series. Okay. So we're now going to go to the next value, which is 1600 Newton meters. And again, what we're going to be doing is just moving very gradually . Okay, so 1600.9, that's within our tolerances. And again, 64.42 is a figure capturing on the output. 64.42. Okay, and from there, 2400. I had a slight bit of overshoot there, but that's within the tolerance we're working to. So we've got the output, 95.89 is the figure on recording. Okay. We're now going to 80% of full scale, which is 3,200 Newton meters. Again, small amount of overshoot there, but the figure I'm capturing is 128.36. We're now going to full scale and our final reading. Okay, so 4,000.6 on the output, 162.94 on the input. Okay, so from here, what we're going to do is now relax. So again, we're going to apply a small amount of tension to the input. We're going to release the anti-wind-up if you've got one on the HT under test. We're then going to release the anti-wind-up on the input drive, and then with control we're going to back off. Okay, we are not going to let go, we're going to be in control. And again, the head's going to come loose, and then we're just going to be checking the output. So again, here, zero torque, zero torque. Okay, from here, what we're going to do is to just remove our crank, disassemble our top plate. Just be mindful, if you have this drive here, your rig may become unstable, so you may well just want to prop this in position. So what we're now going to do is we're going to disconnect our transducer, again because we want to gain access to the HT, because we're actually going to remove it and turn the input. We're going to turn the input, okay, in a clockwise direction until our output square turns by 90 degrees. Okay, so there. So we now have, okay, we now have our HT turned through 90 degrees. Okay, so we're now going to reassemble the rig so we can drop our transducer back in. We can just reconnect. The buzzing you can hear in the background is because the transducer input was disconnected. It's gone over range. We can now zero those figures. We can reassemble the top plate. So I favour dropping in the square. You can leave the square in the drive hand torque. This is my preferred route in here. In here, and then we can just So the rig itself, let's recap. The rig is bolted to the floor. When we bolt it to the floor, we ensure that it's positioned so that you've got a good working area. Okay. What we don't want to be doing is operating the crank with a colleague working in close proximity, and there's a risk of impact. We've got numerous pinch points. There's reaction points here. Reaction points here. These reaction points are movable, so if you're doing counterclock or clockwise calibrations, you can move these points. You've got potential pinch hazards here. Okay, you need to be mindful, and you need to be well read of the manual to understand what those pinch points are. Again, when we're releasing a load, we keep hold of our crank handle. Okay. The rig also has an air connection, which you would have made. Nominal 80-90 psi input pressure. The buttons, you've got an up and a down. Those are clearly labelled on the 80011, which you would have received. So we've got up and down. These are to allow you to drive the input drive plate up and down to best fit the type of multiplier you're working with. Okay, so that pretty much covers the 80011. So what I'm going to say to you now, if you have any questions, consult your Norbar distributor. If your Norbar distributor cannot answer those questions for you, they will come to Norbar and we will do our utmost to answer you in a timely fashion. Thank you.